Hello students, how are you? Hope you are all well. Today I am going to discuss complex number and our topic is the modulus, amplitude form of a complex number. So what does it mean? That means if we take a complex number in the form z equals to x plus iy, then we can transform this Cartesian coordinate into polar coordinate by using the transformation formula from the coordinate geometry as x equals to r cos theta and y equals to r sin theta, where r is, what is r? R is the length of the straight line OP. So OP equals to r, and theta is the angle made by the straight line OP with the positive direction of x axis. So by using this formula, z can be written as r into cos theta plus I sin theta, and you should know that cos theta plus I sin theta can be written in the exponential form as e to the power I theta, and this notation was given by Euler. So e to the power I theta equals to cos theta plus I sin theta is known as Euler's form. However, we want to discuss about the modulus and amplitude. So here r is called the modulus of the complex number z, and it is denoted by mod z equals to r, and the angle theta which the line OP makes with the x-axis in the positive direction is called the amplitude, and we denote the angle as amp z equals to theta. Here capital A means, capital AMPZ means the theta is not unique. It can take so much values, like we can say that the amplitude of z is basically a set given by amplitude z equals to theta plus 2n pi, where n belongs to z. So that's our property of modulus and amplitude, but this is not unique, so we have to find such theta such that we can work properly with that angle. So we define principal amplitude of a complex number. Principal amplitude is nothing but the angle theta. Suppose we name it as theta 1, and the principal amplitude is that angle theta 1 which satisfies this relation minus pi less theta 1 less equals to pi. That angle will be our principal amplitude, and we shall use it in our mathematical problems related to modulus amplitude form of a complex number. So now we want to define how can we find the principal amplitude of a complex number. Let's see. If the point z lie in the first quadrant, then our principal amplitude, which is denoted by small amp, is given by simply theta if this angle is theta. Similarly, if the point z lies in the second quadrant, then z is of the form minus x plus iy. Remember one thing, that x, y should be always made positive, then we can define these quantities. So in the second quadrant, amplitude of z is given by pi minus theta. Similarly, in the third quadrant, we can define amplitude of z equals to minus pi plus theta, and in the fourth quadrant, amplitude of z can be defined as minus of theta. These are the formulas you have to remember, and using these formulas you can easily calculate the principal amplitude of a complex number. So let us take an example related to this. If we take z equals to -1 plus I, then see that the point clearly lies in the second quadrant. So this point lies in the second quadrant, and what we know, in the second quadrant amplitude of z is given by pi minus theta, where theta is simply tan inverse y by x, where x is positive, y is positive. So here if we take x equal to 1, it is greater than 0, y equals to 1, it is greater than 0, then our angle will be pi minus tan inverse 1 by 1, pi minus tan inverse 1 means pi by 4, that means our principal amplitude will be 3 pi by 4. So in this way you can calculate the principal amplitude of the complex numbers. That's all for today. Hope you have enjoyed the class. Thank you.